Hello viewers, in today's class we are going to discuss one important problem from vector algebra, right? So here the problem is, if a cap and b cap are unit vectors, then we have to show that the magnitude of a cap plus b cap is equal to 2 times cosine of theta over 2, right? Where theta is the angle between these two unit vectors a cap and b cap, right? So let us take this vector as a cap and this vector as b cap, and theta is the angle between these two unit vectors, right? So let us start, and here to solve this problem we have to use some important results from vector algebra, right? So here the first result, which is a very important result in vector algebra, which says that the square of a vector vector is equal to square of its magnitude, right? The square of its magnitude, right? So this result will be used to solve this problem. We can solve this problem by some other methods also, but I will prefer to use this result, right? So the square of a vector is equal to the square of its magnitude. So here if we take any vector a, then the magnitude of vector a is denoted by this symbol, right? Sometimes we also write the magnitude by simply writing a, right? So we can also write this result as square of the vector a is equal to the square of its magnitude, right? Okay, so now here see we have the magnitude of a cap plus b cap, right? So let us take the sum of a cap plus b cap as some other vector, say c cap, right? So the sum of the vectors a cap and b cap is equal to c cap. So here we have the magnitude of c cap, and now if we apply this rule to c cap, then we can write the square of c cap is equal to the magnitude of the square of the magnitude of vector c cap, right? Okay, so now viewers, here we can write c cap square as c cap dot c cap, right? Because the square of c cap vector can be written like this, the dot product of c cap with itself, right? And here we have the magnitude of square of the magnitude of c cap, and c cap is a cap plus b cap, and here we have square, right? Okay, so now from the concept of dot product, we know that here see we have c cap is a cap plus b cap, and c cap is again a cap plus b cap, right? And here we have the square of the magnitude of a cap plus b cap, right? Okay, now let us write this expression in the left hand side. So here we have square of the magnitude of a cap plus b cap, and here we have the dot product of these two vectors, now which can be written as a cap dot a cap plus a cap dot b cap plus b cap dot a cap, and here we have b cap dot b cap, right? Okay, now we know that if we have two vectors uh, a and b, then their dot product is defined as ab cos theta, right? So a is the magnitude of vector a, b is the magnitude of vector b, and theta is the angle between vector a and vector b. So now we'll apply this result to this expression. So now we have the square of the magnitude of a cap plus b cap is equal to, here we have magnitude of a, then magnitude of a and cos 0 degrees, right? Because here we have two same vectors, so the angle between a cap and a cap is obviously 0 degrees, right? And now here we have a cap dot b cap, and here we have b cap dot a cap, and we know that the dot product is commutative, so we can write this vector a dot vector b as vector b dot vector a, right? So now these two expressions, when we add them, we get 2 times of a cap dot b cap, and here we have magnitude of b, again magnitude of b, and cos of 0 degrees, right? Because here also the two vectors are same, so the angle between b cap and b cap is 0 degrees. Now we know that a cap and b cap are unit vectors, so the magnitude of a cap is 1, the magnitude of b cap is also 1, right? So now this expression can be written as, here we have 1, here we have 1, cos 0 is 1, and here we have 2 times the dot product of a cap and b cap, so this is magnitude of a, magnitude of b, and cos of theta, right? Because here the angle between a cap and b cap is theta, right? And now here we have 1, because magnitude of b cap is 1, here we have 1, here we have 1. So now we have 1 plus 2 times 1, here we'll have 1, then we have cos theta, and here we have 1, because the magnitude of a cap and b cap is 1, right? So now here we have 1 plus 1, 2, so we have 2 plus 2 cos theta, right? So the square of the magnitude of a cap and b cap is equal to 2 plus 2 cos theta, and now taking 2 common, so we have 1 plus cos theta, right? Now from trigonometry we know the identity that cos of 2 theta is equal to 2 cos square theta minus 1. So replacing theta by theta over 2, we have here cos theta, and here we have 2 cos square theta over 2 minus 1, and taking this minus sign to this side, we have 1 plus cos theta is equal to 2 times cos square theta over 2, right? So 1 plus cos theta is equal to 2 cos square theta over 2. So here we can replace this term by 2 cos square theta over 2, and here we have 4 times cos square theta over 2, right? So now viewers, we have the square of the magnitude of a cap plus b cap is equal to 4 times cos square theta over 2, right? Now this can be written as taking the square root, so here we have 4 cos square theta over 2, and we know that the magnitude of the sum of a cap plus b cap is always positive, so we'll take the positive sign. The square root of 4 is 2, and we have here cos theta over 2. So we have the desired result, right? So this is how we solve this problem.